Here we will be looking at the basic data types in Swift. So we have the 6 basic data types. They are: number one, integers, floating point numbers, then booleans, characters, strings, and optionals. Now let's start with integers. Now integers just represent a number like 1, 2, 3, 4, 5, 6. Those are integers. Like for example, here this is an integer 45. So an integer, this also represents an integer. So they're just used to store whole numbers, either signed positive, negative, or zero, or unsigned non-negative. Now in the integer we have int and uint in Swift. Int and uint. So int are just signed integer data types, and they are platform dependent size, either on 32-bit system or 64-bit system. Now in my Mac, I think I'm in 64-bit. Intel Core i5, 64-bit. Then in uint, u means the uint, it's unsigned integer value type. So, and also they are platform dependent size. Now this is an int, so you see it, a signed integer value type. So now whenever you use int in your code, it will now convert whatever number you type there to the size of your system. Now, if you are using a 32-bit system, then it will sign it to be int 32, a 32-bit signed integer. Then if you are using a 16-bit, 64-bit system, it will sign it as int 64. Then we have int 8, int 8, int 16, and that's it for the int. So whenever this int just encompasses all the bit system with platforms we have: 8-bit, 16-bit, 32-bit, and then 64-bit, depending on your platform. Now these int are just signed integer type, and they're also platform dependent. Now to set an int, just simply say let the variable, then followed by this int. Now let's say age is 30. So you see now what we did here is that we declared a variable which is of type int. So now this int can either be with this can either be for 32-bit system, 64, 8-bit, or 16-bit system. So now depending on the size we put here. And also it can be either a positive, negative, or zero number. So you see it can be zero, it will still be an int, or a negative number, and it will still be an int. So this is one of the basic data types we have in Swift. An int, which is basically a number. Now the int 64, 32, 16-bit, and 8-bit just depends on the system bus of your computer. Now these bits are just the number of bits the system bus can allow at a time. Now back then, I think it started with the 8-bit system, then rose to 16, 32, and 64. All those things are just dependent on the system bus um of your processor or your motherboard. Now we have the unsigned integer. Now the unsigned integer, we declare it like this also, then followed by a semicolon. Then the data type in Swift is uint. Now it can have now a value, let me say 100. Now this is an unsigned integer. Now an unsigned integer can also be platform dependent. Now we can have uint 8-bit unsigned integer value. You can have uint 32-bit unsigned, uint 16-bit, and uint 64-bit. Now if you want to use, if your computer is a 16-bit integer, you use 8. 32-bit you use this, 16-bit you use this, 64 you use this. But whenever you use this, now during compilation and running of your program, Swift will now convert the uint, the value here, to the actual uint bit system of your platform. Also, you can specify it. Let's say you score, say 18-bit. So you can now come here and say uint 8. So this is just like you're not telling the Swift that this is an unsigned integer of a 8-bit platform. So this is basically what we are saying here, and also this is what we are saying here, that this is an unsigned integer. Then Swift will now know what to convert this to, either a 8-bit, 16-bit, 32-bit, or 64-bit. Now the same thing with integer, a signed integer. We can have an 8-bit, 8-bit here. Sorry, 8. I'm using the shift. So we'll come here and say if this 8-bit, you come here int 8. If this for on a platform you are building on 16-bit platform and you want an unsigned or a signed integer for 16-bit, you can do this, then the value. So this is a variable of a number but holding a signed integer of 8-bit system or platform. This is a signed integer, a signed number for 16-bit system. So these are the data types we have in Swift for you now to tell the Swift programming language the data types for the integers. Now, as you can see, integers are numbers from negative numbers to positive, to 0, and to positive numbers, and all of them has its maximum value. Like now, integers has their maximum value. Now, to get the maximum value of a signed integer, you do something like this, max int. So you do something like this, int dot the maximum. So here you get the maximum number or the maximum capacity for a signed integer. Then you can also get the maximum for int 16-bit. So what you do, you say int 16 dot max to give you the maximum number you can reach for a signed integer in 16-bit system. Also, you can, I think this thing should just come up. I'm no longer seeing. Okay, so you can have the maximum. Okay, so have the maximum, and also you can have the minimum for this signed integer. Now let's look at floating point numbers. Floating point numbers are just numbers with decimal points. They are just numbers with decimal points. Then floating point numbers data types in Swift are divided into two. We have double and float. Now, double is just a double precision floating point number that represents a 64-bit floating point number, while float is a single precision floating point type that represents a 32-bit floating point number. Now, to declare a value with a double precision floating point number for a 64-bit floating point number, we do something like this. Now let's say let pi, then for double you use the name double. So as you see, it's a double precision floating point value type. Then for pi, let's say the value of pi is 3.14159. So this variable holds a value which is of a type a double, and a double is a double precision floating point number for 64-bit system. So you see, this is a decimal number like a mathematics. So you just need to know that a double is just a decimal number but for 64-bit system in Swift when you're programming in Swift. Then for float, to define a float number, we do something like this. Then float by C float. As you can see, float says a single precision floating point type. Now float is for 32-bit system. Now float gravity will now say 9.8. So now this variable holds a value which is of float data type in Swift. So now this is a double data type and this is a float data type. This is how it is represented in Swift. Now let's go to Boolean. Booleans are the easiest one. Boolean is just either one, true, or false. Now to create a Boolean variable, we do something like this. Like our previous variable that we created is married, then followed by a colon, then bool. Bool is used the default type for an otherwise unconstrained Boolean literal. So we now type true. Now the only value bool has is either true or false. So those are the two values it represents. So they are the easiest to understand. So either true, this is true, or false. So now the data type, how to represent it is just this bool. Now to represent login or another data type on a boot data type that is of the value false, we do something like this: is logged in and say false. So you see, this is a value that holds the data type boolean, which is false. So these are the two values we use for the boolean data type. Now let's look at another data type we have in Swift, which is the character. The character just represents a single Unicode character. So now to declare a character variable, we do something like this. Let's say first initial followed by colon, then we'll say character. So you see a single extended grapheme cluster that approximates a user. So you see whenever you type, the playground shows you, just brings up the auto completion and shows you in a text the documentation of what you are trying to use. So a character, a single point, a single Unicode character. So it's something like a string but contains only one string. So now let me say my initial C, my first initial, let me change it to C. So now this is a value that holds whose data type is of character. Now we can create another character variable. Let's say second initial, then followed by a colon, then we'll say character. My second initial is N, so we put it here. So if we add any other character, character in this string, it will fail because this character only represents only one character in the string. Now let's look at data type. Now we can use to represent multiple characters in the string. That's where we now come to the strings. The strings is also one of the easiest data type in Swift or programming in general to understand and know. Now let's just call it name. Name. Sorry. Then we'll now say string. Then we'll now come here and add as many characters we want as possible. So this holds my name. And now come here and say today. So today is what? Tuesday. Now say Tuesday. So now this is a variable that holds a value whose data type is a string and this is also a string. So it holds multiple values or multiple characters inside it. That is a string. But if it is a character, it will hold only one. It will hold only one character inside it. Now the last we are going to look at is the optional. The optional is just like undefined we have in JavaScript if you are coming from the JavaScript world. Optional is just used to hold a value or used to represent a value or the absence of a value, which is the case in JavaScript. We have null. So now let's say to declare an optional value, we do something like this. Say optional name. Now the optional does not have a certain type name. Like when we want to declare a boolean, we say bool. When we want to declare a character, we will say character. Or when we want to declare an int, we will say int or int326468 or unsigned int. So now an optional can be of any data type. Now let's just say string. But now to make this now is of a string value or a string data type. But now to make it an optional, we'll add the question mark here. So now this makes it an optional string or an optional value. You can just call it an optional whose value will be a string in the future. So we're just saying this represents a value or absence of a value. So now this is an optional type used with this question mark. Now we can change this string to int. This is now an optional number. Can also change this thing to bool. This is now an optional boolean. We can change it to unsigned int. So this is an optional unsigned int. We can change it to character, and this is an optional character. Then we can come further, maybe just to assign it a value and assign it nil. So you see, this is an optional character. Now, remember we said whatever you define the type of the variable to be is what you must assign it to it. But in this case, this is an optional, and nil can be assigned to it because nil means an absence of a value, which is also an optional. So it's either we assign a character here or nil. It works. Any other thing apart from that, it will not work. So either a nil, it works, or a character, it works. Now, so the same thing as when we change this to a string, either a nil or a string. If we change it to any other thing apart from these two, it will not work. So you see, this is an optional string, optional character, optional int. So this is how the optional data type works in Swift.